Welcome to the University of West Florida College Algebra Lecture Series, Section 7.1. In this section, we are covering systems of equations and how to verify that a potential point is a solution to the system of equations, and also then to solve for the solution of the system of equations. And in particular, when we're talking about system of equations, what we're talking about is intersection of two straight lines. So we're going to be learning how to solve systems of equations in two ways. The first way is going to be called the substitution method. The second option is called the elimination method, or also sometimes called the addition method. Let's first, though, check to see how we can tell if a point is actually a solution to the system of equations. An ordered pair is a solution to the system of equations if it solves both equations. So when I look at a point, it has to solve or satisfy each equation, not just one. When you're taking the SAT or the ACT, you will often find that the point will actually solve one of the two equations, but only one point can be a solution to two linear lines, and that is the one known intersection of the two lines. So that's what you would have to solve, is to verify that both lines meet the qualifications for the solution. So to determine if the point -3, -5 is a solution to the system of equations, this system right here, we're going to simply plug in the points into X and into Y and see if it makes the statement a true statement. So remember, this is your X, this is your Y. So we're going to plug in X right here and Y right here. And then again, X right here, Y right here. And then if it balances and makes these to be true statements, we know that we found a solution to the system of equations. So the first check is going to be 4 times X. X is -3 minus 2 times Y, which is -5, equals -2. That's the question. Is this a true statement? Well, 4 times -3 is -12. -2 times -5 gives you a +10. And the question is, does that equal -2? Well, sure it does. -12 plus 10 is -2. So that checks. So we know that this point right here is a solution to this equation right here. Whether it is a solution to the system of equations yet remains to be seen. So now we're going to take this value and plug it into X here and Y into this value right here and see if we end up with a true statement. So 3 times -3 plus 2 times -5. The question is, does that equal -19? Well, -3 times 3 is -9, and 2 times -5 is -10. Does that equal -19? Sure it does. -9 plus -10 is -19, and that equals -19. So this point also satisfies this particular equation. Since this one point is a solution to both equations, that means this one point is the intersection of these two lines. The substitution method will be the first method that we're going to learn how to use. Step 1 for the substitution method is solve one equation for one variable. Which equation it is, it doesn't matter, just pick one. Step 2, substitute this solution into the other equation to get an equation in one variable. You must substitute into the other equation. Very important. Step 3, solve for the one variable. And then step 4, solve for the other variable. Let me go ahead and demonstrate how this works. So on example 2, it says solve for the system of equations using the method substitution. So the method is specified. Here you're going to notice that we've already solved for one variable. The problem was set up like that, so we didn't have to do any work to actually do step 1. Step 1 says solve for one variable, or one equation for one variable. So we have y is equal to 5x minus 18. That right there is step 1, y equals something. Step 2 says substitute this into the other equation. So my other equation is 2x minus 3y equals 2. So I'm going to take this information and I'm going to substitute it in right there. So to rewrite that, this will be step 2, actually, what I'm writing down right now. So that's 2x minus 3 times y. Y is equal to 5x minus 18. So we're going to put what y equals, 5x minus 18 right here, equals 2. All I did was substitute in what y equals right there. Now I'm going to use the distributive property and distribute my negative 3. So I get 2x minus 3 times 5 is 15x, so negative 15x. Negative times a negative is going to give me a positive. 3 times 18 is 54, and that is going to then equal 2. I'm going to combine like terms on the left, and I'm going to go 2x minus negative 15x gives me negative 13x plus 54 equals 2. Next, I'm going to move my 54 over from the left to the right-hand side of my equal sign, and I'm going to add straight down. So I have negative 13x is equal to negative 52. My negative 13 is connected to my x through multiplication, so I'm going to use division to move my negative 13 over to the right-hand side of the equation, and I get, therefore, x is equal to, a negative divided by a negative is positive, 52 divided by 13 is 4. So x equals positive 4. Now I'm going to come up here and I'm going to substitute all of this information into my next equation so I can solve for the other variable. That would be step 4. So I have y is equal to 5 times x is 4, minus 18. Y is equal to 20 minus 18, which equals 2. Therefore, y is equal to 2. So now I'm going to put this together and write it as a coordinate so that I can say my solution is the point 4, 2. And that point right there is the one point that both of these lines have in common, and it occurs at the intersection of those two lines. So my solution is the point 4, 2. Go ahead and pause the video and plug both of these numbers back into our original equations and make sure that they check out. This is what you should do on your exam whenever you take an exam. Example 3, solving the system of equations using the substitution method. The first thing I want to do is go ahead and choose an equation to solve for one of the variables. Since the first equation here all has multiples of 5, I'm going to choose to solve the first equation for y. So if I have 15x minus 5y minus, or equals rather, negative 10. I'm solving for y. So I'm going to move my 15x over. What I do to one side, I must do to the other side. Add going straight down, I get negative 5y is equal to negative 15x minus 10. I'm going to divide both sides through by negative 5 because remember, I am solving for y. And what I do to one side, I must do to the other. So I'm going to get, therefore, y is equal to negative 15 divided by negative 5x plus, because I have a negative divided by a negative, is going to be plus 10 divided by 5. Let's make this a little bit better. So I can say a negative divided by a negative is positive 3x plus 2. So that is what y equals. And again, I did this on the first equation. So I'm going to take this y that I solved for the first equation, and I'm going to substitute it into the second equation right here and solve for my variable. So my second equation is 3x plus 2y is equal to negative 7. I'm going to take this value right here and I'm going to plug it in right there. So I end up with 3x plus 2 times 3x plus 2 is equal to negative 7. Use the distributive property and distribute the 2. 3x plus 6x plus 4 is equal to negative 7. Combine like terms. 9x plus 4 is equal to negative 7. Subtract 4 from both sides, and I get 9x is equal to negative 11. Divide both sides through by 9, and I get therefore x is equal to negative 11 ninths. Take this value right here, and we're going to plug it back into right up here and solve for y. So taking this right here, and I'm going to substitute it in right there. So now I have y is equal to 3 times negative 11 divided by 9 plus 2, and I'm solving for y. I can take and I can simplify right here. 3 will go into 3 one time, 3 will go into 9 3 times. So now I have y is equal to negative 11 divided by 3 plus 2. I need a common denominator right here. So my common denominator is going to be 3. So this is going to become negative 11 divided by 3 plus 6 divided by 3, and that is equal to negative 5 divided by 3. So that is what my y is equal. So therefore, y is equal to negative 5 divided by 3. My solution then for this equation is, so my solution is the point negative 11 ninths and negative 5 thirds. So right up there is my solution. So that is my solution to problem 3. Got a little messy with fractions, but that's okay. We can handle that. Next, let me go ahead and highlight my workspace so that we know where the new problem starts and where the old problem ends. Why don't you go ahead and pause the video right now and solve number 4 on your own using the substitution method. I'll see you back in just a minute to see if you got the right answer. Welcome back. So the first thing I would do is I would say I'm going to take the second equation right here again because I saw multiples and solve for y. So I have 2y minus 4x is equal to 2. I'm solving for y, so I'm going to add 4x to both sides. So now I have 2y is equal to 4x plus 2. I'm going to divide both sides through by 2. Therefore, y is equal to 4 divided by 2 is 2x. 2 divided by 2 is plus 1. So y is equal to 2x plus 1. Now we're going to take this information and we're going to plug it back in up here. So I have negative 6x plus 3 times y. Y is 2x plus 1. That must equal 3. I'm going to solve for x. So I have negative 6x. 3 times 2 is 6, so plus 6x. 3 plus, or times 1 is 3, so plus 3 is equal to 3. Negative 6x plus 6x goes to 0, and I end up with 3 is equal to 3. This is a very true statement, but it also tells me that I have parallel lines that are actually laying on top of each other. This is simply a multiple of this. So they're actually the exact same line laying on top of each other. I can put any common point for x, solve for y, and it will be on the line. And so we have an infinite number of solutions. So therefore, we have an infinite number of solutions. Okay. Now, our next method is called the elimination method. The elimination method, or the addition method, step 1 is you eliminate one of the variables. Step 2, solve for the variable in the resulting equation, because you're going to have one equation, one variable. Step 3, solve for the other variable by substituting back in what you solved for the first variable. So here we go. Let's practice this with example 5. So using the process of elimination, the objective is to see if I can add these two equations together and have a variable disappear. Since I have different coefficients for both variables, I'm going to have to manipulate one of the two equations in order to have them to add together to nothing. If you'll notice that these two variables are multiples of each other. If I multiply 3 times 2, I will get 6. Not only will I get 6, I'll get a negative 6. Negative 6 plus a positive 6 will eliminate my y, and that's what I want to do. So I'm going to take and multiply 2 by the top equation right here. So that's going to be 4x minus 3y is equal to negative 13. I'm going to multiply that 2 all the way through. Then I'm just going to write this one down right here. So it's 5x plus 6y is equal to 13. And I'm adding them together. First thing I'm going to do is simply multiply this all the way across. So I end up getting 8x minus 6y is equal to negative 26. And now I'm just going to copy down the other equation. Add these two together. I get 8x plus 5x, and I get 13x. Negative 6y plus positive 6y goes to 0. So now I've eliminated my y, and that is going to be equal to negative 26 plus 13, and that is going to give me a negative 13. I'm solving for x, and in order to do that, I'm going to divide through by 13 over here. What I do to one side, I do to the other, and therefore x is equal to negative 1. Now that I know that x equals negative 1, I can substitute it back in to an original equation and solve for y. So let's just go ahead and substitute it back into the second equation right here. And so I will say that I have 5 times x, which is negative 1, plus 6y is equal to 13. 5 times negative 1 is negative 5, plus 6y is equal to 13. Add 5 to both sides, and I get 6y is equal to 18. Divide both sides through by 6, and I get therefore y is equal to 3. So my solution is the point negative 1, 3. So my solution is the point negative 1, 3. This is the one point that is common to both equations. It is the intersection of the two lines. Going on to our next problem right here, we're going to solve equation 6 using the method of elimination. And I'm going to encourage you to go ahead and pause the video, solve it on your own, and then push play to see if you get the right answer. Okay, this one here was a little bit more difficult than the other ones that we've seen, because you're going to notice that neither one of these have a coefficient that will easily cancel out. So I'm going to actually have to manipulate both equations. So I'm just going to rewrite down right here the first equation, which is 3x plus 3y is equal to 5. And the second equation is 2x plus 4y equals 8. So I'm going to need to manipulate these. So if I take this first equation right here and I multiply it by a negative 2, what you're going to notice is this right here becomes a negative 6. And if I multiply this equation right here by a positive 3, this becomes a positive 6. So that when I add them together, I end up with a negative 6 plus a positive 6 equals 0 x's. So I've eliminated x. So that's what I'm going to be doing right here. So rewriting this, negative 2 times 3x is negative 6x. Negative 2 times 3 is negative 6y. Negative 2 times 5 is negative 10. 3 times 2x is positive 6x. 3 times 4 is plus 12y. And then 3 times 8 is 24. Now I have two equations that I can add together, and I will eliminate one of the variables. This one right here. Negative 6x plus 6x goes to 0. My x is gone. Bam. Okay, now we're going to add together our coefficients for our y. Negative 6 plus 12 gives me a positive 6y. Negative 10 plus 24 is equal to positive 14. I'm going to solve for y, so I'm going to have 6y is equal to 14. Divide both sides through by 6, and I get therefore y is equal to 14 divided by 6, but 2 will go into both of those, so that is really 7/3. Okay, now that I know that what y equals, let's substitute that back into an equation. Let's just do the first one and solve for x. So we're going to substitute this in. So we have 3x plus 3y. What does y equal? It equals 7/3. And that is equal to 5. Well, notice my 3's go right away. So I end up with 3x plus 7 is equal to 5. Solving for x, I'm going to subtract 7 from both sides. And I get 3x is equal to negative 2. To solve for x, I need to get x by itself, so I'm going to divide through by 3 on both sides, and I get therefore x is equal to negative 2/3. So this gives me my solution. So my solution is the point x is negative 2/3, negative 2/3, and my y is 7/3. So that is my solution for this problem. How'd you all do? If you got this one correct, send your instructor here at UWF the code word VASE. The code word VASE. And then we'll know that you got it right. For attendance purposes, if you didn't get it right, but you tried, send the code word YARN. Y-A-R-N. Yarn, like you're going to crochet or knit something. Alrighty, here we go for our next problem. I'm going to highlight through here since I kind of worked in the next space right there. Let me grab a different color ink so we have some contrast going on. We're looking at problem number 7, and the first thing I'm going to want to do is go ahead and manipulate the second equation here by 2, because if you look, you're going to see that by multiplying my 5 by 2 or a negative 2, my coefficient or my variable x will disappear. So I have negative 10x plus 2y is equal to 26. My second equation is negative 5x plus y is equal to 7. I'm going to multiply this equation right here by negative 2. And I'm going to rewrite the equation system as negative 10x plus 2y is equal to 26. Negative 2 times negative 5 is a positive 10x. Negative 2 times a positive is negative 2y. Negative 2 times 7 is negative 14. Add these together. Negative 10x plus 10x goes to 0. 2y minus 2y also goes to 0. 26 minus 14 is 12. Since 0 does not equal 12, we have what's known as a contradiction. So therefore, this is a contradiction, which means there is no solution, no real solution. Okay, so we have a contradiction, therefore we know there is no solution. Alrighty, our last problem, here we go. It says, graphically, the solution to the system of equation is the point where the two lines intersect. So that would be like this point right here. It says, what do you think the solution would be if the lines were parallel? Well, if they're parallel, they never intersect, right? They just keep running beside each other the whole time. So if I drew a line like this, right next to this blue line right here, they would never intersect, so therefore there would be no solution. And if they are the same line, like one is literally right on top of the other, then we would have infinite solutions. Okay, so again, if we have parallel lines, there is no solution. If they have the same line, then we have infinite number of solutions. Well, guess what, guys? You have just made it to the end of college algebra at the University of West Florida. Congratulations. I'm so proud that you made it all the way through to this lecture. I would like you to send the code word Jack and Jill went up the hill to your UWF instructor so that he or she will know that you actually finished the lecture all the way. High five, we're very proud of you. Study hard for this next exam so that you can ace it. Okay? Take care. Remember, the code word are Jack and Jill went up the hill. Take care.